Lesson 11-2, Solving Quadratic Equations by Graphing. And in this lesson, you'll learn to use estimation to find roots of quadratic equations and to find roots of quadratic equations by graphing. Why is it important? Because you can use quadratic equations to solve problems involving architecture and number theory. And let's take a look at the real-world application in technology. In the United States, one of the fastest growing industries is the production of CD-ROMs for computers. CD-ROM stands for Compact Disk Read Only Memory. CD-ROMs can hold text, music, photos, images, or combinations of any of these. Any company that produces a product to sell finds that the profit they can make depends on the number of employees they have, among other things. So let me repeat this. The profit that they can make depends on the number of employees that they have, among other things. So basically what you're saying is that the independent variable will be your number of employees and the dependent variable will be your profit. This tells you right away which is on the x-axis and which is on the y-axis. So the relationship between profit and number of employees looks like a parabola drawn at the right. Okay, so this is your parabola. Okay, the company does not make much profit if there are too few employees. Okay, as they hire more employees, the work can be done more efficiently, leading to higher profit. So as you increase the number of employees, the profit increases. But if the company hires too many employees, look what happens to the profit. Okay, uh, it may not have room for them for them or enough work for them to do, yet they still have to be paid, causing lower profits. So what this parabola is saying, as you increase the number of employees, the profit increases, but there will come a time that when you increase more employees, the profit decreases because they might not have enough to do, but still they are getting paid. Okay, so this is a good example of a real life parabola problem. Okay, so since number of employees is the independent variable and profit is the dependent variable, the domain and range must both be positive. Again, we're talking about uh, no such thing as negative and negative money and negative number of employees. So we are stuck or we just remain in quadrant 1 of our coordinate plane. Okay? So suppose a company that produces CD-ROMs can express its profit as P of X equals negative 0.1 x squared plus 200x, where X is the number of employees in the company. So as the personal manager of the company, it is your job to determine the least number of employees the company should have in order to reach its goal of having $75,000 in profit. And we will solve this in example number 4. Okay, before we do that, let us look at the same problem. Okay, and let's talk about a quadratic equation. So let's define a quadratic equation. A quadratic equation is an equation in which the value of the related function is related quadratic function is 0. Remember that a quadratic function is equal to y equals ax squared plus bx plus c. That is a quadratic function. Okay? A quadratic equation is that you simply equate the y to 0. So this becomes now 0 equals ax squared plus by or bx plus c. So that is for the quadratic equation, 0 equals x squared plus 6x minus 7 is considered to be a quadratic equation. The related quadratic function is f of x equals x squared plus 6x minus 7, where f of x is equal to 0. Okay, so go back to what we learned in the past. Remember our x and y intercept. Okay, when we want to find our x-intercept, okay, we equate y to 0. And remember what the x-intercept is. This is the point where it intercepts the x-axis. Okay, so this is the point where it intersects the x-axis. And just remember that particular concept as we move on with this lesson. So you have used factoring to solve fraction or equations like x squared plus 6x minus 0 using the zero product property. So you can also use graphing to estimate the solutions to this equation. Okay, so let's use graphing. The solutions of a quadratic equations are called the roots of the equation. The roots of the quadratic equations can be found by finding the x-intercepts or the zeros of the related function. Basically, as you find the x-intercept, okay, of our quadratic equation, okay, these are called your roots. So the roots indicate the x-intercept of your quadratic equation. Okay, so let's move on. Okay, and let's solve x squared minus 2x minus 3 equals 0 by graphing. Okay, so we want to check this by we want to solve this by graphing, and we want to check our solution by factoring. So first things first, graph the related function f of x, okay, equals x squared minus 2x minus 3. So to be able to find the values of x squared minus 2x minus 3, you need to graph the function f of x equals x squared minus 2x minus 3. So the equation of the axis of symmetry is equal to 1. Remember, we learned this in the first lesson, that the axis of symmetry, okay, is equal to x equals negative b all over 2a. Okay, and if we substitute here, in this case, our a is equal to 1 and our b is equal to negative 2. And if we substitute that, okay, our axis of symmetry therefore would be negative 2 all over 2 times 1, or simply 1. Okay, and that's why you have 1 right here. Okay, so and the coordinates of the vertex are 1 and 4. Again, we know how to find this. We simply get 1 and substitute it back to our quadratic function, and we end up with y equals negative 4. And that's how we got the vertex 1, negative 4. And if we also notice, okay, the coefficient of our quadratic term is positive, so this parabola opens upward. Okay, so make a table of values to find the other points to sketch the graph of f of x equals x squared minus 2x minus 3. Okay, so you'll make a table of values, and this is the table of values that was given. So if x is negative 1, f of x is equal to 0, or y equals 0. If x is 0, f of x is negative 3, and so on and so forth until you have 5 points. If x is equal to 3, your y, or f of x, is equal to 0. So if we graph these points, this is what we're going to get. Okay, right there. That's our parabola. That's our vertex. Minimum point of 1, negative 4. Okay, and if you notice, it crosses the x-axis at 2 points. It crosses it at negative 1, and it crosses it at positive 3. Okay, so to solve the equation of x squared minus 2x minus 3 equals 0, we need to know where the value of f of x is. We need to know where the value of f of x is 0. So we're basically finding the roots of our quadratic equation, or where our parabola intersects our x-axis. And we know that it intersects at negative 1 and positive 3. So on the graph, this occurs at the x-intercept. We talked about that. And the x-intercepts of our parabola appear to be negative 1 and 3. So after we find the roots, let's check it by factoring. And let's use x squared minus 2x minus 3 equals 0. And let's factor it using the power of x. Okay, using the power of x, we now find that it's going to be x minus 3 and x plus 1. And using the zero product property, we have now x minus 3 equals 0, and which is the value is 3, and the other one would be x plus 1. Where is it? Oh, at the bottom. It's x plus 1 equals 0, or x equals negative 1. And this checks out. The solutions of the equation are 3 and negative 1. Okay? Let's move on to the next example. In example 1, the zeros of the function were integers. Okay, so that's fine. If the zeros of our function are integers, that's easy to find. Usually though, the zeros of the quadratic equation are not integers. So in these cases, we need to use estimation to approximate the roots of the equation. Okay, so if the roots of our quadratic equation, or if the x-intercepts of our quadratic equation are not integers, we need to estimate the approximate value of our roots. Okay, and let's take a look at example number 2 and see how it works. We want to solve x squared plus 9x plus 5 equals 0 by graphing. So if integral roots cannot be found, basically integral means integer. If I were going to restate this, if the roots are not, if integer roots cannot be found, okay, so just use integral, sounds better. So if integral roots cannot be found, estimate the roots by stating the consecutive integers by which the roots lie. Basically what it's saying is that if you have consecutive integers 2 and 3 right there on our x-axis, and our parabola, let's say, passes through that, okay, we want to find that point. And that's what it means here, by stating the consecutive integers between which the roots lie. So in this case, our consecutive integers are 2 and 3. Okay? So let's move on, and let's use a table of values to graph the related function f of x equals x squared plus 9x plus 5. So if we graph a table of values, we find this, okay, substituting negative 9 for x and finding f of x, and moving down the line we have negative 9. If x is negative 9, f of x is equal to 5, and so on and so forth. If x is 0, f of x is equal to 5. And if we graph these table of values, this is the graph we're going to get, okay? And if you notice right here, okay, we circle it and enlarge, and let me just enlarge that point right there, okay? So if you notice, our line passes in between negative 9 and negative 8, and this case, on this side, okay, it passes here, right there. Oops. Doesn't want to do that. Let me do that again. Okay. So right there. There you go. Okay. The negative 1 and 0 right there. That's negative 1 and that's 0. Okay. Now I can't close it. There you go. Oh, nice. There you go. Okay, let me close that one. So in this case, we know that is where, okay, our line passes through. And through graphing, we are able to estimate, okay, our x-intercepts. So the x-intercepts of the graph are between negative 9 and negative 8, and between negative 1 and 0. So one root of the equation is between negative 9 and negative 8, and the other root is between negative 1 and 0. Okay? Or we can write this as one root, okay, the roots of our quadratic equation will be between, it is greater than negative 9 but less than negative 8, and it is also greater than, okay, negative 1 but less than 0. So these are our possible, two possible roots. Okay, let's move on. So quadratic equations always have two roots. Okay, they always have two roots. Okay. However, these roots may not be two distinct numbers, meaning two numbers that we don't really recognize, okay, two real numbers. So let's take a look at example number 3 and see how these there are exceptions to our two roots that are not distinct numbers. Okay, we want to solve x squared minus 12x plus 36 equals 0 by graphing. So we want to graph the related function f of x equals x squared minus 12x plus 36. And we create our table of values, and this is what we find after we substitute x to our quadratic function. We end up with the values of f of x, okay? And the equation of the the equation of the axis of symmetry is x equals 6, again using our formula of x equals negative b over 2a. The vertex is 6, 0. Okay, so after finding a vertex, we can now graph our quadratic function. And you know that the coefficient of our quadratic term is 1 or positive. That means a parabola opens upward, and this is how it looks like. And if you notice, it only the vertex touches the x-axis. So there is only one x-intercept in this case. So in this particular scenario, okay, the vertex of the parabola is the x-intercept. Thus, one solution is 6. Okay, so what is the other solution? Okay, the other solution, we'll try factoring to see if we can find it. Okay, so if we have x squared minus 12x plus 36 equals 0, and we factor that, we find out that x squared minus 12x plus 36 is a perfect square trinomial. And if we factor this as a perfect square trinomial, this becomes x minus 6 times x minus 6 equals 0. And if we use the zero product property, we end up with x minus 6 equals 0, which is 6, and x minus 6 equals 0 again, which is equal to 6. So in this case, there are two identical roots to this equation. So there is only one distinct root. Okay, so there's only one distinct root. So the solution for x squared minus 12x plus 36 equals 0 is equal to 6. Okay? So when you have your vertex, okay, as your only root, that means you only have one distinct root for your quadratic equation. Okay? Let us take a look at another scenario, which is example 4. So thus far, we have seen that the quadratic equations can have two distinct real roots or one distinct real root. Okay? So is it possible that there may be no real roots? Okay, so let's take a look at solving x squared plus 2x plus 5 equals 0 by graphing. And then we graph the related function f of x equals x squared plus 2x plus 5, and we create our table of values. Okay, so we substitute negative 3, negative 2, negative 1, 0, and 1 to our quadratic function. I'm sorry. And we find our f of x is 8, 5, 4, 5, and 8. Okay, so the equation of the axis of symmetry, okay, after solving x equals negative b all over 2a will be equal to negative 1. And our vertex of our parabola after substituting x equals negative 1 to our equation would be 4. That's our f of x if x is equal to negative 1. So we have the vertex of our parabola as negative 1, 4. And again, we have a positive coefficient for our quadratic term. So therefore, this parabola opens upward. And if we graph these table of values, okay, and that is our vertex, negative 1, 4 right there. This is how our parabola will look like. Okay, that's our vertex. It opens upward. And if you notice, it does not intersect the x-axis at any point. So what does this tell us? This graph has no x-intercept, thus there are no real number solutions for this equation. Okay, so even though quadratic equations always have two roots. They are not always distinct. So in this case, okay, there are no real number solutions for this equation. The symbol no null set, no solution, indicating an empty set, is often used to represent no real solution. Okay, and let's take a look at example number 5. Quadratic equations can be used to solve number problems. Okay, let's look at the example 5 and see how this works. Two numbers have a sum of 4. What are the numbers if their product is negative 12? Okay, so this is an easy problem, and you probably can do this in your head. But let's walk through this and let's see how a quadratic equation can help you solve this. So let n represent one of the numbers, then the other number is 4 minus n. Okay, again, if you don't get this, just think of this. Let's say, let me give a random example. Uh, the sum of two numbers is, let's say, 10. Okay, if the sum of two numbers is 10, okay, and one of the numbers is 7, okay, so if the sum, this is just an example, of two numbers is 10, okay, and one of them is 7, okay, therefore the other number would be 10 minus 7, okay, or 3, right? Now, if the sum of two numbers is 10 and one of them is n, what would be the other number? Okay, so just like what we did here, if 7 is equal to n, therefore this would be 10 minus n. Okay, so following that logic, so if we have two numbers whose sum is 4 and n represents one of the number, then the other number is logically 4 minus n. Okay, so how do we plan to solve this problem? A function that describes the product of these two numbers would be f of n equals 4 times the first one number is 4 times 4 minus n, or f of n equals negative n squared plus 4n, because the function is f of n equals n times 4 minus n, and we use the distributive property. This becomes negative n squared plus 4n. So we want to find the value of n if f of n equals negative 12. Why? Because it says there two numbers have a sum of 4. What are the numbers if their product is negative 12? Okay, again, look at the coefficient of our quadratic term. It's negative, therefore our parabola opens downward. We know that. Okay, so how do we solve this? We solved f of n equals negative n squared plus 4n if f of n equals negative 12. Therefore, this becomes negative 12. We simply substitute negative 12 to f of n, okay, equals negative n squared plus 4n, okay, and then we add 12 to both sides so we can equate this to 0, okay, so we now have 0 equals negative n squared plus 4n plus 12. And then we will graph the related function of this quadratic equation, which is f of n equals negative negative n squared plus 4n plus 12. And we create a table of values for these. Okay, any value of n will do. So these are the values of n that was used, negative 3 all the way down to 7. And these are the corresponding values of f of n if n were equal to negative 3, negative 2, negative 1, all the way down to 7. F of n would be negative 9, 0, 7, all the way down to negative 9. So the equation, again, we want to find the axis of symmetry is equal to n equals 2, and the vertex, okay, of the parabola is 2, 16. So again, it's a negative coefficient of our quadratic term, so this parabola opens downward. And if we graph these table of values, this is what we're going to get for our parabola right there. Okay, and if you notice right now, okay, it will intersect our x-axis right there at -2, and it will also intersect plus our x-axis on the other side. Oh, never mind, I'll just make another square. Okay, at right there 6. Okay, so it intersects our x-axis at -2, and it intersects our x-axis on the other side at 6. So our x-intercepts are -2 and 6. Okay, so what does this mean? Okay, from there, we're not going to the next page because it's just at the bottom. Okay, from there, the n-intercepts of the graph are -2 and 6. We use these values of n to find the value of the other number, 4 minus n. So we use -2 to represent n. We use 6 to represent n as well. So if n equals -2, then 4 minus n equals 6. And if n equals 6, then 4 minus n would be -2. Okay? So the numbers are 6 and -2. Does that make sense? If not, rewind it, pause it, rewind it again, or pause it again until you more or less get it. And please have the book in front of you so for better understanding. So if you want to check our answer if it works or not, okay, test to see if the numbers satisfy the problem. The sum of the numbers is 4. So 6 plus -2 is 4. So we got that right. Okay. And the other part of the problem is that the product of the numbers is -12, and 6 times -2 is equal to -12. So it checks out. The two numbers are -2 and 6. Okay, and the secret word for this particular lesson would be winter. The secret word is winter. Okay, thank you for watching.